friends, welcome to my channel. I hope everyone is doing good. Today we are going to solve another extremely popular coding problem. It's on Leetcode 690, employee importance. So this is a medium complexity, very popular coding question. So we are going to look into this problem. I created some nice examples so that you can clearly understand the logic approach as well as the solution how to solve this coding problem. If you are new to this channel, please subscribe to this channel now. Your subscription is really valuable and important for our channel. It helps and supports this channel. So guys, let's start. You have a data structure of employee information including employees unique ID, importance value and direct subordinates IDs. You are given an array of employees where employee ID is the ID of ith employee. Okay, employee I dot importance is importance value of the ith employee. Okay, and employee I dot subordinates is list of IDs of the direct subordinates of the ith employee. Given an integer ID that represents employee ID, return total importance value of this employee and all their direct and indirect subordinates. Okay, so this is what the problem says. A very good problem. So we'll understand this with some examples. So employees length can be maximum 2000. Employee I.id is 2000 and employee I.id are unique, and importance can be minus 100 to plus 100 inclusive. Let's take a look at some example. So in the first example, you can see that this employees array is given to us. If you plot a tree like this, right, you will see a tree like this. So ID1 has an importance 5, right? So where it is coming from? Because they have given us here, right? 1 has an importance 5. And what is this 2, 3? 2, 3 is a subordinates of 1. So you will see that these are the children, right? 2 and 3. Okay, again 2 will have a importance value of 3 as they have given us, and 3 will have importance value of 3. So this part is clear to you guys, right? How this tree came. So this tree came from this input that they have given us. Okay, now id is equal to 1. So id, they can give us any id 1, 2, 3. In that case we have to find out the importance value. So what is the total importance value? The importance of that node and all its basically subordinates, means all its children, or like basically you have to take all of its subtrees children basically. Okay, so 5 plus 3 plus 3, which will give you 11. So that's why answer is 11, right? Here is another example. Here in this case, this is a simple tree that you have id1 and id5, only two nodes, and id5 is given to us, so its importance is minus 3, so you will return minus 3. Okay, fine. So I created another very good example. It's similar but it's a little different. Okay, so in this case you will see that this input is given to us, right? So you can see that one has a children, one has importance value 5 and its children are 2, 3. So one has an importance value 5 and its children are 2 and 3, correct? Okay, 2's importance value is 3. You can see 2's importance is 3, yes, and its children are 4 and 5. 4 and 5 are the children. Okay, 3's importance value is 3, right? You can see 3's importance value is 3. It does not have any children. 4's importance is 6. As you can see, no children. And 5's importance is 8. No children. Okay, so this you understood how this tree came actually from this input, right? Okay, so now they have given us one input node. The input node will be same as 1 in that example, right? So input node is 1. So you have to find out importance value starting with this node. So what is importance value? Value of this node plus value of whole subtree of left side and subtree of right side, basically, correct? That is the importance value. Okay, so let's calculate it quickly. So 5 plus 3, which is 5 plus 6 is 11. 11 plus 8 is 19 plus 6 is 25. That's why the answer is 25. Okay, so now you understood that answer, how that answer came, right? Okay, let's see how we can actually solve this problem now. So let me just copy this and move it little bit left side, right? So I can write it here. Okay, so now I can use a very important technique here, which is very famous technique also, which is called as BFS, right? BFS stands for breadth first search or breadth first traversal, right? How will we use a BFS here, we can use a BFS by using a queue, right? We use queue here. So what we will do in that queue, so let's say I have this queue. So first thing, I will go through this employees list that is given to me, and I'll find out the employee for the input node, right? So I want to calculate value for node 1. So I will start to traverse through this array and find out node 1 value. Okay, node 1 value is this. So what I will do, I will add this node here in my tree, in my queue, right? So what will be the node has? Node has two things, 1 and 5. So 1 is the node 1, and 5 is its importance value. After that, I will start removing these nodes in the BFS, right? This is how BFS works. So you remove the node, so you will get 1 5, right? So importance value, you create one sum variable, right? And you add that importance value here. So it's 0 in the beginning. Now you added 5, right? And when you remove this 1, you will add its children. So children are 2 and 3, right? So I removed this 1, I will add 2, its importance value is 3, right? And so like this basically, so this is what I will add, and what I will add, I'll add 3, and its importance value is 3, correct? So this is how BFS will work internally. I am just explaining it to the guys who doesn't know it, so that it will be clear for them. Okay, so next time what you will do, you will remove this 2 and you will add this 3 value into sum. So your sum becomes 8, right? And you add the children into the queue. So 2 children are 4 and 5. So 4 comma 6 you add here, right? 4 comma 6 you add, because 4 and the importance value 6. 5 comma 8 you add, right? 5 comma 8 you add. Okay, 5 and 8. Okay guys, so these are the children you added. After that you will remove 3, you add the importance value 3 into 8, so it becomes 11. Next time you will remove this node 4, it does not have children, its importance value is 6, you add 6 to 11, right? So it becomes 17. Next time you will remove this 5 and 8, no children can be added because it doesn't have any children. 8 value needs to be added to 17, and it will give you 25 basically, correct? So this is how BFS solution we can uh, apply to solve this employee importance coding problem. So I hope you understood how the BFS solution works here clearly with this example. So now is the time to take a look into our Java code, right? So let me show you our Java code now. Okay, so this is our Java solution code, guys. So get importance is what we are implementing. A list of employees is given to us, ID is the given to us, right? So first you will start iterating through this list of employees. Whenever you get a employee which is matching with the ID that is given to you, then we will start using the BFS on that employee, right? So what we will pass, we will pass the employees list here, and we will pass the employee, correct, that we want to start the BFS with. Okay, now this is where our BFS is, employees list is there, the employee is there, right? And this returns int, which is the total importance, right, uh, for that employee. So queue employee is equal to new linked list. So the queue is nothing but it's going to hold employee objects, right? So you will offer the this employee object that we found, right, which is here, right? We found for this ID, this employee object. So that's what we will start with, right? So we need to put something in that queue to start with. So we'll start with this employee that we have, right? And then sum is 0 in the beginning. This is a typical BFS implementation in this while loop, right? So BFS starts basically, right? So that's what we are doing. So while queue is not empty, you will remove that employee object from the queue. You add the importance of this current employee into your sum, and you will have to iterate through all the subordinates of that current employee, correct? So you are going to go through all the children basically. So e dot subordinates id. Now here you will say employees e2. So whenever you have this id value is matching with your employee, then that employee you have to add. So you are adding the children basically into the queue, correct? So for example, for 2, when you process 2, what are the children of 2? You will get 4 and 5 are the children of 2, because that is given to you in the input, right? So like this. Okay, so you will keep iterating through this while loop, and you will keep processing all the nodes. but you will only process those nodes which are coming in the left and right subtree of the selected node. This is a very important thing to understand. Okay, so for example, what I mean to say is, if I am starting my BFS with this node, then only I will add these two nodes. I will not be concerned about these two nodes in that case, right? Because they are not a part of the left and right subtree. Okay, that's the important point I'm trying to tell you guys. So at the end, you have to just return the sum, and the sum will give you the total sum of the employee for that, basically for that employee. Okay, so this is how the BFS works. So let us give it a go and make sure this code is compiling correctly and running against the test cases correctly. So this is the example that I created for you guys. We are expecting 25 as the answer, and here we are getting 25, which is correct answer, right? And if I take a look at other 11 correct answer, test case 2 -3 correct answer. Submit this code now to the Leetcode. Make sure the code gets accepted by the Leetcode. And as you can see on the left side, the code is successfully accepted. Let's try to resubmit this. The numbers doesn't look good or correct, so I'm not sure about these numbers. It showed me some other numbers before, but this is how you can use BFS to solve this coding problem. It's on Leetcode 690, employee importance, a very popular coding interview question that we have solved by using BFS. Okay, so I hope that this example I created for you guys help you understand this problem in a clear and easier way. Guys, it takes lots of creativity, time and efforts to create these examples and images. So if you really want to appreciate our efforts that we are taking here, then please subscribe to our channel now. Click on the bell notification icon button so you won't miss any important videos from our channel. Share this video with all your friends so they can also watch and learn from these videos. And Definitely share these videos. And if you like this example, give a like for this video as well. Your like is very important for our videos. On this channel, we create content and videos to help others learn more data structures, algorithmic paradigms, and problem solving, Java programming and coding. We have more than 600 solved coding problems for you guys. Those problems are selective. Those are asked by big companies such as Amazon, Apple, Microsoft, Google, Meta, and a lot of big companies. And we came up with very important playlist that is important from interview perspective. So the important playlist includes graphs, matrices, binary trees, problems solved by using important techniques such as binary search, dynamic programming, recursion, memoization, how to use and apply BFS and DFS on graphs, matrices, and trees. The important data structures related playlist includes queues, stacks, linked list, arrays. Right, everything is here on this channel for you guys. So don't miss out on those important solved coding problems. If you are a Java consultant, we have important videos for you that discusses frequently asked Java interview questions, which are telephonic interview questions, and how to answer those telephonic questions, right? So search on our channel, you will find those videos here. Thanks for watching this video and have a great day ahead.